All right, so yesterday I was concerned we didn't quite finish talking about domain and range and evaluating a function from a graph we kind of skipped. So did we go over these two yesterday at the bottom of worksheet 1B? We did not. Okay. I thought we ran out of time. Okay. The idea, remember, for domain in particular, which is all this question asks, the domain is all real numbers for any kind of polynomial like this, or these are actually a rational function and something wonky, unless there's two things. Anybody remember what they are? If there's a denominator, the denominator cannot equal 0. Okay, there's an x in the denominator. Everybody knows what denominator means, right? If there's something in the denominator at the bottom, that cannot equal 0. And if there's any kind of a square root, what's underneath here, under any radical, must be greater than or equal to 0. Can only take the square root of a positive number. So, the domain for this number 10, if you graphed it, you'd need parentheses around the top and the bottom. But when you looked at the graph, it would be super hard to tell where these breaks are. Okay? What we need to know algebraically is that this denominator cannot equal 0. How could we find those places? What could we do to that? Factors? How does it factor? Anybody awake? Factors of 15? Okay. Make an 8 in the middle, a negative 8. We're good? So if we set each one equal to 0, oh, I lost my work there. The two values would be 3 over here and 5 over here that are causing a break in the graph. So the domain could be all real numbers except x cannot equal 3 or 5. There's a painful way to write that in interval notation, but since I didn't put that on the quiz tomorrow, I'm just going to leave it like that, okay? Number 11, a little bit of this idea is on the quiz tomorrow, but not this complicated. The idea here is there's a denominator, but what's in the denominator? Okay, a square root. Anytime there's a radical, what's underneath the radical has to be positive or greater than or equal to 0. But what's wrong with this particular problem? Yes, the denominator cannot equal 0. We talked about that here, remember? So now what's in the denominator can't equal 0. So what do we need to do to change this? We just need to get rid of that or equal to. And that's a tricky idea. I did not put that on the quiz. But once you know what's underneath the radical, you solve this for x. And then how do you state in interval notation that x has to be greater than 5? Can anybody tell me that? Okay, which one? This gets a bracket? No, if it's greater than, it's, yeah, because it can't be equal to, it's just a parenthesis. All right, we'll practice some more in a second. I did have one more example, I think, here. Do you have this number 12? Okay, this has a denominator, so what would we say? The denominator can't equal 0. So real quick, if we factor out an x, what are the two values that would make that 0? If we set that equal to 0, we'd just have x equals 0. If we set that one equal to 0, we'd get what? So it's all real numbers except x cannot equal 0 or 3, and I'm just going to leave it at that. Okay, there's a question like this on the quiz. Wants the domain and range. Now, you can graph it. I think it's going to look something like this, okay? But it's going to be hard to get an exact value. You have to do some algebra. What do you know when there's a radical? What's underneath the radical has to be in terms of a domain. Can only take a square root if that number is what's under the radical has to be greater than or equal to 0, okay? Positive or 0. So you have to say this is greater than or equal to 0. If you add 9 over to the other side and you divide by 9, you get 9 halves, or 4.5 is an exact answer, I don't care. So the domain is 4.5. I'm just gonna leave it 9 halves. If you wrote 4.5, it wouldn't be wrong. Okay, 9 halves and up. And it actually can include 9 halves. If I put 9 halves in here, I get the square root of 0, which is 0. Okay? That's the domain, and there's one like that on the quiz. What about the range, though? This particular one, I want the range. If you looked at the graph and it looked like this, anybody tell me bottom to top? Yes. And it can equal 0. And that again has to do with the fact that you can take the square root of 0 and get out a 0, but nothing smaller, okay? I'm gonna make a class announcement here. About half of you need to pull your mask up, please. We're getting all kinds of kids sent home because they weren't wearing their mask properly and someone in the room had COVID. If you have your mask on, you don't have to quarantine. All right, I have a few more examples. Please pay attention because this was not discussed well yesterday, or at all, possibly. First of all, domain and range. Can you guys see this one well enough? I don't think you have this example, but can you see what's happening here? Domain, remember, is left to right. So can you tell what the furthest left x value is? -3, yeah, I think so. And it's an open circle, so we'd have everybody good? And then what about going to the right? Yeah, this arrow's continuing to the right. Are you okay? So it would go to infinity. Antoine, did you have a question? Okay. The range, guys, remember, is y values, and it's bottom to top. So what does the tippy bottom here seem to be at? -4, and it does seem to hit it. There's no open circle down there. And the top? Again, this is going up on this side, so we'd say infinity. All right, this is the new stuff we didn't get a chance to talk about yesterday, and hopefully it's super easy and you won't have a problem. How do you look at that graph and find f of 0? It simply means when x equals 0, if this function drawn here is f of x, okay? If x is 0, what is y? So if x is 0, it means we went across none. Well, where did we end up then? Down here at -4. Everybody okay with what I'm talking about? So can you tell me what f of 3 would be? When x is 3, the graph appears to be at... Anybody lost? Okay, let's practice a little more. Let's do that part first on these. F of 0. So if I put a 0 in here, what am I getting out? Seems to be 0. F of 1. When I put a 1 in for x, I seem to get a y value of, okay, f of 2. That one looks like 0. All right, what is the domain and range on number 2? It appears to get wider and wider, right, as it goes? And what about up and down? Continually goes up and down, so you'd have all real numbers? Everybody okay? Yes.
So do we have to find a 0 and a 1? Is that going to be on the quiz?
Yes. It's evaluating a graph, evaluating a function from a graph.
Okay.
And that is on the quiz. I don't know if I have one more example. I think on the notes there is, on the review. Okay. Questions. Any questions before we look at the review? Okay, what about questions from the review? Or do you want me to just start at the top and talk through some? You tell me. Is there a particular spot you want me to talk about? Okay. If I ask you to state vertex form, you need to know vertex form. Though it may be somewhere on the quiz in the directions to a problem. If you get confused, look for it, okay? But what does vertex form say? Y equals x minus h plus k. Okay. So for this particular one, can you tell me the vertex without ever putting it on the calculator? It's the opposite of this, so it's +4 and +1. Oh my goodness. Pretty sure I can't see that graph paper. I don't know if I can make that. Not really. Okay, I'm just going to attempt to count. 1, 2, 3, 4, 1. I don't know. All right. Then if you wanted more points, okay, you could plot it on the calculator and do what? Yeah, go to the table. Do we need to take time to do that on this one, or you want me to just keep going? So I have 0, 9 as a point on there. 4, 1, we already got that's the vertex, sorry. 2, 3 is a point. Now what else should I know then if I know those 3 points? There should be some symmetry to this, yes? And it should be rounded at the bottom, not a V. Other than that, I'm not very picky. Well, I barely hit the dots, but. Any questions? You all know how to type that in? You know how to look at the table to find some ordered pairs? All right, also a part of that is to use the calculator to find the vertex, the y-intercept, and the x-intercepts. Do we need to practice that? Yes? Okay, type this one in real fast. Y equals 6x squared minus 24x plus 5. What do you notice right away if you do a zoom 6? Yeah, you can't see the bottom. So what would be a good thing to do to find the bottom? Okay, is it X or Y that I will need to see more of? I need to see down, so that is a Y value, and it is the min. So maybe like -20. Try that, see if that's enough. That looks pretty good. Now, I could try to zoom in and find a better, I could stretch it, but it's fine. I can see what I need to see. All right, how do we find the vertex? Second trace. This one is what? Minimum. And it's somewhere down here, but I'm just gonna hit enter because it's between there and maybe 5. I got 2 negative 19. This is calculator error, so I just take that as 2 negative 19. Someone having trouble? Yes. If we just go to the graph, I think it's changing it. Yeah, just go ahead and hit graph, okay? And then we did min. All right, so we got down to 2 negative 11. And that was the vertex. The y-intercept, how do we find where it crosses the y, guys? Do you remember? It's up here somewhere. What do you know about on the y-axis? The x value is? Guys, you're killing me here. If you're at a point on the y-axis, the x value is 0. So you can go trace 0 and enter, or you can look at the table. But 0, 5 is the y-intercept. Okay, doesn't look like we're going to get nice x-intercepts. How do we find those x-intercepts? Second trace, choose 0. And I'm to the left of that first one. And then if I scroll past it, I'm to the right. And it finds that one, 0.22. Then if I do second trace 0, now this time I need to make sure I'm over close to this one. I'm to the left of it. Okay. What is that garbage? Negative 3e negative 12. It's negative 3 times 10 to the negative 12th, which would be negative 0.00000000003 maybe, which is basically 0, right? So that's just calculator error. So we'd write down 3.78. How are we doing? Who's stuck? Yes. Not accurately, because the y-intercept would be there. That's a great question. But you're trying to find where y equals 0, and you will notice there is no place where y equals 0 nicely. It's somewhere, in between 0 and 1, and so on. You could, if you had to do it without a calculator, you'd have to do quadratic formula. Okay? So, can anybody remind me real fast what those were so I can fill this in? Was it 2 negative 11? 2 negative 19? 0, 5? Thank you. It does say round to the nearest hundredth on the quiz, I believe. Okay. This is right vertex form. Anybody remember how this goes? If this says, I think it says 3, negative 1, what are those 2 points called if that's the vertex? Guys, this is not that tricky. We just got to remember how it went. The vertex is H and K, and we're going to use that other point, whatever we have, to plug in for X and Y. And what are we trying to find? We can plug all this in right now. We know the answer is going to be y equals x minus h, which is 3, squared, plus k, which is negative 1. What am I missing, though? The a. I have to do some work to find the a. Does everybody remember now kind of how we did this? Okay. So we went with this equation and we plugged in all of these numbers. So y was 2, a we're looking for, x is 0, minus h would be minus 3 squared, plus k is negative 1. Okay, then it got a little tricky because students want to do some crazy algebra, but what do we have to do here? This just becomes negative 3 squared is 9. Is this 9 minus 1 is 8? No, because this is 9 times a. So then we can add the 1 over to the other side and get 3. Now that answer is not 3. Be careful. You're dividing by 9, so you end up with 1/3. And then remember, you could graph it on the calculator. I graphed that, and I checked that it went through, what was it supposed to go through? 0, 2. Okay. One more, or you want me to skip this one? One more? Okay. We're going to plug in the vertex is h and k. This point we're going to call x and a y. We start with vertex form. We plug those numbers in. What's it going to say, guys? Help me out. Okay, so what am I putting in for y? 9. I'm looking for a. I'm putting in for x. 8 minus h would be minus 3 squared. Don't forget the squared. Plus k would be, yeah, k is negative 11. All right. This is multiplied together. So to get rid of that 11, I would add it over to the other side and get 20. And what is 8 minus 3 and then squared? Times 25. So to get the a by itself, I'd have 20 over 25, which I think if you reduce by 5 is 4/5. Does that sound right, guys? So the final answer would be y equals 4/5 x minus 3 squared minus 11, because again, you're putting the vertex in. So I graphed it, okay, and I made sure it went through 8, 9, and that the vertex was at 3, negative 11 to check that it worked. Questions on those? All right, do we need to practice this section? You want me to save this for if there's time, or what do you want me to do here? How do you find the height at 1.8 seconds? Yeah, you just say x equals 1.8. You could literally type it in there, or if you've graphed it, you can do trace 1.8. How do you find the time till it hits the ground? What do we find in there? Yes, you use the 0 feature. Left bound, right bound. Can you have a negative time? No. So you have to find this one, which on this, looks like I got 4.84. Do you need me to model that? No one's saying anything. Yes.
How many of these do you have on some of the other?
1. Yep, just 1. All right. This section is what we did yesterday. Evaluating functions. Again, this is the one we didn't cover very well yesterday. So look carefully. This means when x equals 0. So I need an ordered pair that goes 0 something. Can you tell from the graph? Across 0 looks like it's up at 3 or 2.8. I don't care because it's hard to tell. What is this saying though? If I go left 3, what is the y value? 1, 2, 3. Well, it's right there, so the y value appears to be 0. I have one extra one I threw on here. F of negative 2. If I said you were to go left 2, the graph looks like it's right up about 3 again. Are we okay? That we're going to do well on that part tomorrow? Reading from the graph? Okay. What about this? You just got to put in the number, right? So if I did this one just because it's got a negative, and you'd have to remember the parentheses. This would be 3 plus 6 plus 7. You can use your calculator for all that, but I'm getting 16. Did anybody get 16 on that one? Okay. So you just put the 4 in. Any questions on those? All right. Is the above graph a function? That was the one that looked like a W, right? Then they go like this. Is that a function? Yes, why? Yep, you could say passes the vertical line test, and I'd be okay with that. Draw a graph that's not a function. What could you draw? Circle, sideways parabola, anything that would fail the vertical line test. Write a list of ordered pairs that is not a function and explain why. So I need some ordered pairs, but I need it to not be a function. How would I know it's not a function? Okay, so 2 of them have the same x, right? Okay, explain why the x's repeat. Okay, it would, if I graphed it, I went over 2, up 3, over 1, up 4, over 2, down 6, over 9, up 9. Well, these two line up, right? So to fail the vertical line test. Any questions? Okay. Ooh, this one worries me. How's this gonna go? I think this one is harder than the one on the quiz. You have to put in a minus 4 in here. Remember this? 3 times a minus 4 squared minus 6 times a minus 4 plus 7. But it says you have to simplify. Can I distribute the 3 through here? Can I square each of these? Do you remember? Yeah, you have to FOIL it out. So we got this 3 out here I'm going to ignore for a minute. But in here we have an a minus 4 times an a minus 4. And there's no shortcut unless you have memorized the pattern. But it is not a squared plus 16. Okay. And then we got the rest of this stuff going on back here. Like I said, the one on the quiz is not quite this complicated. But if I FOIL this together, I get an a squared minus 4a, another minus 4a, and then a negative 4 times a negative 4 is plus 16. There's still that 3 out front, unfortunately. Okay, do you want to simplify before we distribute? What is minus 4a minus 4a? Yeah, this becomes a minus 8a. Now let's go ahead and multiply everything by 3, and that's the step I don't think you have to do on the quiz tomorrow. You'd have a 3a squared. 3 times that negative 8, ugh, it's negative 24a. So many places to make a mistake here, right? 3 times 16, I believe, is 48. And then I didn't bother to rewrite it again, but we still got all this stuff down here. Minus 6 times A. Be careful, then what? Plus 24. And that plus 7 on the back. Okay. We got a 3A squared. I'm thinking that's minus 30A. And then I don't know what that is. A 79? Okay, that was nice and disgusting. Like I said, I don't think the one on the quiz has that 3 out front. That is just one more step of nightmare-ishness. Is there another example in that section or not? No? Anybody have a question? Need me? All right. Then domain and range. There is a question that you have to use your calculator for. It says find the domain and range of this. Can everybody graph that in their calculator real quick? Negative 2x to the fourth plus x cubed plus 2x plus 5. Can anybody read it to me as you type it in? Negative, was it negative 2x to the fourth? Arrow to the right, and then plus x to the third, arrow to the right. Okay, do I have it right? Negative 2x to the fourth plus x cubed plus 2x plus 5. Okay, if I try a zoom 6, that's actually not too bad of a window. Domain and range is what we're looking for here. Can you tell what's happening in terms of left to right? It's a little hard to tell, but does this appear to be going further and further to the left, and this appears to be going further and further to the right? The other thing is, do you remember the domain restrictions other than some wonky graph? This is a polynomial. Is there a denominator or a radical anywhere in it? No, so what is the domain? All real numbers. Yeah, negative infinity to infinity. It's going left and, it's hard to tell, but it's going left and right forever, okay? But the range is not that. Bottom to top. Bottom, it's forever, right? Which we write what? Negative infinity. But what do we need to find for that top? We need to find that max. And what do we want from the max? Range is a y value. So we need to find the max. Second trace max. And it's somewhere between, I don't know, 0 and 2. I got 0.78 and 6.29. Okay? Which of those do I write down though? If I'm finding the range, I want the top y value. Everybody good? So you write down 6.29. And it should be inclusive. Yes, should be a bracket. If there's no open circle, we're going to say we're ending about there. Okay. Got it? Domain and range of this guy? It's going left and right forever. What about up and down? Yeah, good job. The bottom y value is 0 and up. Okay. What about algebraically this guy? You could try graphing it, but I'm not too sure it's going to be as helpful as you think. I don't think I tried graphing it. Square root of... Okay. The issue is, what is somebody going to say? Is it gonna look, it doesn't look like it's touching that, does it? Okay, but if you trace over there, okay, could I trace any slower? If you trace over there, yeah, see, this is where you're going to get it wrong if you don't know the algebra. It's very hard to tell what's happening. What is the algebra we talked about? Anything underneath a radical has to be what? Greater than or equal to 0. So if I solve that, x is greater than or equal to -8. So the domain, we got close on the calculator. It was -8 and going to the right, right? Look like that. Oh my gosh. Well, not that bad. It looked like that. How's that? So it was -8 to the right, but somebody's going to put a parenthesis here. It actually needs to be a bracket because you can, if you were to hit -8 when you were tracing here, it does show up at, it is 0. Okay, it can be 0. So what's the bottom to top business? Remember, what was the y value here? Yeah, this is 0 and up. How you feeling? Domain and range. Graphing problems. Do you need me to go back and do that throw up problem? Find a good window for it? I don't know if we have time. I think we do. If I type this in, -16x squared plus 75x plus 12, remember you trade those out for x's. I don't remember. What did it say after that? Plus 75x x plus 5? That's 12? Yeah, okay. If I try it with a standard window, not so good. An appropriate window would be to have no negative x's because that's time. And I definitely needed to look up higher. I have no idea what, I'm going to try 300. Yeah, that's way too much, but it'll work. Okay, how do we find the time at, was it 1.8? Want the height at 1.8 or something? So we just go trace 1.8, enter, or you could, well, it's not going to be on the table unless you adjust your table. So 95.16, did someone else get that? Okay. And then it says how long until it hits the ground. That's the 0. And the one we're looking for is over here. So we could say it's between 1, 2, 3, 4, and 6 seconds somewhere. I like to type those in, but you can scroll around if you want. And again, this is garbage. This is calculator error, e to the -11th. So I got 4.84. What was this? 95.16? Did I hear right? And that is, I think, feet. Does it say somewhere? Yeah, there's an actual word problem that goes with this on the quiz. I just skipped that part of went right to the equation because that's what you type in. With this, we had 0 to 10, and this, I don't know, 0 to like 100 probably would have worked. I guess I had 150 or -10 to 100. I didn't actually ask you for the window this time. Another time I will, but this time I let it slide, and just as long as you can find a window that'll give you the answers, you're good. Questions? Did I go over the whole review? I think we skipped this one, but... 48 minus 24. 24. I don't know. I got 31. Did anyone else get 31 on that one? Was that everything on the review? Okay, we made it. Any questions on the homework? Delta math? Something I can go over?